today, while I'm walking around and checking off that homework assignment for you, what I need you to go ahead and take care of for me are two things. You started these yesterday as you were leaving class, but there are 4 questions, very important questions to be honest with you, at the end of the first section of notes in chapter 2. So I'd like you to finish those 4 questions from yesterday if you did not do so already. After you finish those 4 questions, you can go ahead and turn to the next page, and then what you will see is a FOIL warm-up. There are 6 problems for you to go ahead and FOIL on the next page of notes. So all in all, you're responding to, would that be 10 items, while I check off some homework for you, and then we'll talk about these answers, of course, together as a class in a few minutes. Okay, so right now you're going to turn back to the first part of P4, and I just want to sort of conclude yesterday's lesson a little bit, put a nice little bow on it. Hey, Emma, what method should we always try first? Perfect. For GCF method or greatest common factor method. Do you know why? Perfect. You used my words even. Very good. Yeah, the answer to that why is because it's not going to be factored completely, quote unquote, if you don't take out a GCF first. Very, very good, Emma. Well said. Number 2 says, how can you recognize a difference of 2 perfect squares? Now, why these types of questions are important? Because how are you going to remember to use the square root method if you don't even recognize what a difference of 2 squares is? So, man, Alex B. Okay, so they could both have variables though last night, huh? Like last night we did x squared minus 4y squared. So that was also a difference of 2 perfect squares. I think you were hinting at it though. You have a minus sign, right? Because by definition a difference in math class has to be a minus or a subtraction problem. Okay, now what else? There's 2 other characteristics. Right, because it has to have 2 terms. Good. And then what's special about those 2 terms? Yeah, very good. So you could use that square root on them. Very good. Okay. Hey, Brooke, how do you recognize a perfect square trinomial? Okay, let me help you work through this a little bit maybe. Trinomial, what's that mean, Brooke? 3, so there has to be 3 terms. Okay, now there's only one piece of that phrase left, perfect square. So if you look up at the marker board right now, I went over 24, 27, 28. Those 3 problems were perfect square trinomials. So if you look at 24, 27, and 28, they're trinomials because they have 3 terms, but what else do they have in common? You use they a little bit liberally there. When you say they, specifically what are perfect squares in the problem? Do all 3 terms have to be perfect squares? No. Yeah, which 2, Brooke? They have the little green thing around them. Do you see? See the pattern? Yeah, there you go. Okay. To summarize, to make it pretty so that you could write it in your notes, 3 terms where the first and last term are perfect squares. This is where you would try to use the square root method. So Brooke, that one that you were asking me about that Mrs. Owens was helping you out with, we would square root the first part, square root the last part, and that helps you get the numbers in the parentheses. You'd play around with the signs a little bit in between to see how you would get the middle term back out. Does that make sense? So that was number 3. Number 4 goes to Nikki. First of all, x squared plus 4. Does it factor? That's what you were trying to figure out. Does it factor? X squared plus 4. So let's play around with this thing, Nikki. What you were supposed to do is kind of guess and check your way through it. You know that when we factor, Nikki, we're trying to like populate 2 sets of parentheses, right? Trying to fill in those blanks. What would you maybe play around with to try to figure out how this thing factors? What would you put in there? I'm so sorry, I just couldn't hear you. X and 2. And then what signs would you use in between? You really can't, yeah. Even if you tried plus and plus, right? You're looking at, oh, apparently my marker didn't want to be in my hand anymore. Oh, stop! Okay, so if you FOIL this, you get x squared plus 4x plus 4. Well, that's not equal to x squared plus 4. There's a 4x term hanging out in there. So this can't be right. What else might you try? John, you tried 2 negatives and you got it to not work, right? So John tried this. And yeah, what you would get if you FOILed this guy here, so if we did a little FOIL action on those 2 binomials, you'd have x squared minus 4x plus 4. Again, ugh, you get this middle term. So annoying. So that can't work. Did you have something else to say? Yeah, because that's x squared minus 4, isn't it? So this is not factorable, ever. What I need you, if you're like, okay, lady, get to the point already. Okay, here's the point. The point is this. We can never factor a sum of 2 squares. We can factor a difference of 2 squares, but we can't factor a sum. Eyes on the prize, factoring is a tool, people. It helps us solve for x. And when we solve for x, bless you, when we solve for x in this class, a lot of times we're finding places where a graph crosses the x-axis. Well, if I draw you a picture of x squared plus 4, that's a parabola hanging up 4 units on the y-axis. That graph never crosses the x-axis. So there's no solutions for x, which means there's no possible way you could find real factors for this problem. It's just not possible. So you can factor a difference of 2 squares, but you cannot factor a sum of 2 squares. You good with that? Okay, now, next up, I wanted you to be able to check your warm-up from that. So I'm going to go ahead and post the completed notes for that so that you can kind of check to make sure your foiling skills are still nice and sharp. So here those answers come for you. There it is. So if you could take a moment just to check your FOIL answers from the next page, that'll be good. I'll check off a couple more homework. The blank, filled in the blank. Yeah, okay. All right, so on to the next. I am showing you how to factor, all in all today, 2 types of problems. And they're the very same 2 types of problems that you just FOILed to get. So when you look at, for instance, A, B, and C, do you see how I have like 6x squared sort of highlighted there? Okay, that's going to be the second type of problem we factor today, where there's a number in front of your x squared. The first type of problem we're going to factor today is still a trinomial, but there's no number in front of the x squared. Ben, turn around, honey. Thank you. So there's no number in front of the x squared. Furthermore, take a look at these problems that you just FOILed. Could you use the square root method that we talked about yesterday on these problems? Consider it. You'd be taking like square root of 6, square root of 12, square root of 5. Does that work out? No. Not very prettily anyway. So yeah, we couldn't use the method that we talked about yesterday either. So yeah, our new methods for today involve asking yourself a question. So for first of all, we're asked to factor something simple like x squared minus 7x plus 12. The first thing you want to consider is that the a value in this problem is 1. That's your number in front of x squared. The b value in this problem is negative 7. Bless you. And then the c value is 12. And the question you ask yourself is, what are the factors of c that add to b? This will help you factor these types of problems quickly and efficiently. So I have to think to myself, what numbers multiply to give me positive 12? And you're drawing a little thinking cloud too right now. Oh, yes, you are, because what goes on the smartboard goes in your notes. You're asking yourself, what are the things that multiply to give you 12, but then add to negative 7? What are the things that multiply to give you positive 12, but then add to negative 7? Go ahead, John. Yes. But do those add? Oh, yes. Oop, I can't write today. You're good. So negative 3 times negative 4 is positive 12, and negative 3 plus negative 4 is indeed negative 7. All right, so now what do we do with these numbers? Well, you know that ultimately we're trying to stuff 2 sets of parentheses. We're trying to, fill in 2 binomials. So what I have to ask myself specifically to get what's in these first positions here in my parentheses is what multiplies to give me x squared? Well, that's real simple because we did that yesterday. Things that multiply to give you x squared would just be x and x. To get the second pieces of your parentheses, you just go off of what you found in the previous step. So the rest of the parentheses are going to get filled in by negative 3 and negative 4. The last step, we always check it with FOIL. So if I FOIL this, x times x is x squared. My outers is negative 4x. My inners is negative 3x. And my last is positive 12. When I combine my outers and my inners, I indeed get negative 7x. So that checks out. My final correct answer for this particular problem is x minus 3 times the quantity of x minus 4. All right, you try. Additional example, x squared plus x minus 6. See if you can repeat this process for me. Kind of took a quick look around there. Looks like most of you are on the right track. You were thinking to yourself, what multiplies to give you negative 6, but then adds to be a positive 1. Anybody feel comfortable spilling the beans about their numbers? Good, Chris. 3 times negative 2 multiplies to give you negative 6, and 3 plus negative 2 does indeed give you negative 1, so that works. Good job. When you factored it, Chris, what did your answer look like? What goes in the parentheses? Good. And if you FOILed it, did it work there, Chris? Yeah. So you do have to check with FOIL. Last method of the day. What happens if we stick a number in front of that x squared? This is called AC grouping. And I'm going to walk you through the steps. Notice the visual difference here. Do you see how there's a number in front of the x squared? And that number is 6. And I can't square root method. And I can't take it out as a GCF. I'm stuck. Let's consider why the previous method wouldn't work before I jump on into this guy. If I look at the previous method, it would only have me looking at this 5 at the very end. And I would be forced to think about numbers that multiply to give you 5, but add to 17. Multiply to give you 5 that add to 17? That's not possible. So you have to pull in that a value. In other words, the number in front of x squared. This method is called AC grouping. You use it when there's a number in front of x squared that can't be taken away with the GCF method. And furthermore, you can't square root method that. You can't square root 6 and have it come out pretty. So step 1 is, well, this is how the method gets its name, right? It's called the AC method. So step 1 is to multiply A times C. A in this problem is 6, C in this problem is 5. The product of A and C would be 6 times 5, which is 30. In step 2, we now think of the factors of A times C. So I'm thinking of two numbers that multiply to give me 30 that add to my B value. In this case, they have to add to 17. Bless you. So factors of AC that add to B. We're going to finish this method up tomorrow.